I worked so hard training and deploying multiple machine learning models to get a prediction for cardiovascular disease that by the end of this whole exercise, I am sick and my chest hurts. Seriously. No. Jokes aside, I just wanted to cover the backend code, and I thought the best way to do that was to break it down into two-part series. The first part will cover the selection process among multiple models and show you the backend code, the actual Python code that I use to deploy this cardiovascular disease model with the gradient boosting, cat boosting algorithm that I ended up selecting. So that'll be the first part. And the second part will be to see that model once it's been deployed. We pick that up and we serve it up using Flask so that everyone has access to it over the internet and you can actually get to play with it and see the model in action. Speaking of model in action, there are a couple other videos that actually goes into showing you the model once it's been deployed using Flask in action, so you can experiment with multiple different values to see what the prediction is going to be. So I'm going to link up those two videos at the end of this video so you can always refer back to those as well. So let's get going. All right, so the first thing I wanted to show you which are all the different types of algorithms that I decided to experiment with before selecting the one that I ended up using for deployment. So let's look at each one of them quickly. So the first one is the support vector machine, so that's the first one that I looked at. And then I also looked at random forest classification, naive Bayes. I looked at logistic regression. I experimented with kernel support vector machine or kernel SVM, looked at k-nearest neighbor, and then decision tree classification algorithm. I even looked at kernel PCA with logistic regression. Finally, I started looking at the gradient boosting algorithms, XGBoost and catboost. So that's the extent to which I experimented before I ended up selecting catboost to deploy. Now, I'm not going to go through the backend code for every single one of them. It's essentially following the same process. It's just that you're training and deploying using the different algorithms. So I'm going to just go back and show you something else here. So I went through multiple selection steps multiple times. I went through them and finally I selected, I believe there were a handful that I ended up selecting, experimenting with. So I ended up selecting catboost and kernel SVM. Those were the final two selections, and I want to show you those codes in just a moment and why I ended up deciding with catboost as opposed to kernel SVM. But I wanted to show you the data. I believe this is the data. So let me just open it up so you have a generic sense of how the data looks. So this is the extent of the data, not too many columns. Age, gender, height, weight, blood pressure high, blood pressure low, cholesterol, glucose, smoking indicator, alcohol consumption indicator, activity indicator, and finally the results, which is whether the person is predicted to be cardiovascular disease patient or not. So that's the extent of the data, and not too many columns, as I said. So now let's look at the code. So if I go back into Jupyter Notebook, and I have here kernel SVM, and I'm just going to put this one here so they are next to each other. So kernel SVM is the first one I looked at, and then I looked at catboost algorithm. So kernel SVM, essentially the same process I'm following: importing the library, importing the dataset that we just saw, splitting the dataset between training and test. Then we are doing some feature scaling using standard scaler. We are training with the kernel SVM model or the algorithm, and we are doing some performance evaluation using confusion metrics, and then we are also looking at accuracy using k-fold cross validation. Now, the only thing I want you to keep in mind from this training and deployment is that for kernel SVM with confusion metrics, we got an accuracy score of roughly 72 to 73%. And when I ran that model against a careful cross-validation matrix, I ended up getting an accuracy of 72.71% and the standard deviation being 0.51%. So just to keep that in mind, you can always come back to that. Then comes the one that I ultimately ended up selecting. So it's worth spending a bit more time on this one here. Okay, same process. I'm going to import the libraries. One of the libraries that I didn't have that I needed to install was catboost, obviously. So I did that catboost installation. I did the importation of all the libraries, numpy, matplotlib, because I wanted to explore the data a bit, pandas, and pickle. So this is how we are going to get the executable generated so that we can serve it up using Flask later on. So again, the same idea, importing the dataset that we just saw, and then the exploration of the data. So I wanted to investigate a little bit. So first thing I did is a check to see if there are any missing values. So we ended up finding that there are no missing values, none whatsoever, which is great. Now the rows and columns, I had a quick glimpse at the rows and columns. I got a sense of how the data looks by running the head, so the first few rows, to give us a sense of how the data looks. And I wanted to get to see the types of data that's there here under data types. Prior to that, I also looked at the different column names. So here you can see all of them are the same type, integer 64. So then we get to see the description of the data. So this is where I wanted to get a detailed view of the data. So all these steps that I'm executing right now is just to get a sense of the data, explore the data a bit, which is always a great practice. Identify any negative values for blood pressure. So I wanted to get a sense if there are any negative values, and it just happened to be for high blood pressure, there are some negative values, not too many, but there are a handful. And also there's one negative value, one row with a negative low blood pressure. So what I ended up doing, I ended up removing them from my data set. So essentially I'm cleaning the data at this point. So I did that, and then after dropping all the negative data sets values, I'm just gonna get a count. I wanted to get a count of how many rows and columns are there, and here we can see that there are that many columns, or that many rows rather, 6,000 or 69,992 rows and 12 columns. And I also wanted to see what the value counts are based on the final column, which is our results column, cardio. And I noticed that there are 35,017 that are no cardiovascular disease, or 0, and 34,975 that are cardiovascular disease. So that means 1. So pretty evenly divided, the data set, which is always great. Now the next thing I did, I imported Seaborn because I wanted to plot a certain way to get further exploration done on the data. So here I'm looking at how it plots based on gender. So we can see that depending on the gender, you'll get different counts, whether there are more cardiovascular diseases for one gender to the next. You get a sense of that. And after that, I also looked at cholesterol. Based on cholesterol, whether it's going to divide, whether there is any pattern that we can identify. So this is where we are going to do some pattern identification, right? So we're exploring to see if there are any patterns that we can see. Obviously, smoking is given that, if for smokers, you expect to see that there'll be higher number of detections of cardiovascular disease, and that's exactly what it's showing here. So you can see that there are more cardiovascular disease and for the smokers, and less cardiovascular disease for the non-smokers. Now the next thing is alcohol consumption, again a key marker I think for cardiovascular disease, and you can see that that's exactly the case. For those who consume alcohol, irrespective of the gender, there's a higher chance of cardiovascular disease versus those that don't consume alcohol. That's what I'm reading from this. And let's see. Now the other one that I looked at is activity. So if you are less active, obviously your chances are higher to get cardiovascular disease. That's what is showing the data. So that's how I explored the data. Now the next thing that I did is feature selection and labeling the data. So that's what I'm doing here. I selected all of the columns except for the final column being X, and the final column, which is a results column, being Y. Now once I've done that, I came down to splitting the data, and I used the 80-20 rule. I used 80% of the data to train and 20% of the data to test. So, and it also tells me how many falls into each category for training and test. Now this is where I'm actually going to select the catboost algorithm, and I'm going to train my model using catboost. So that's what I'm doing here. I imported catboost classifier. It's important to keep in mind catboost can be used for both regression and classification type problem resolution. So here we have a classification situation, so we ended up selecting catboost classifier. So then the classifier is a catboost classifier, and then I'm fitting the data on that model, and that's what I'm doing here. So that's done. So now our catboost model is trained, fully trained. Let's look at the performance of it. That's where I brought in the confusion matrix. That's what I'm doing here with the confusion matrix. We're looking at the accuracy score, and at the end of that evaluation, it just turns out with confusion matrix, our catboost based gradient boosting model ended up giving us an accuracy of 74%. So that's great, because if you compare that, and we'll compare that with our kernel SVM, if you remember under confusion matrix we got about 72%. So obviously this one has given us a better accuracy, so that's part of the reason I ended up selecting it. Now I also ran the k-fold cross validation to get an accuracy measure that way, and it was around the same 73.59% accuracy and 0.56% standard deviation. Let's quickly look at how it was for kernel SVM. So 72.71%, which was lower, and 0.51% standard deviation. So all in all, based on all the different models that I experimented with, it turned out that catboost model was the way to go. So that's how I ended up selecting the catboost gradient boosting model to train and deploy my model. And the way I deployed it is by using the pickle library. I believe that I imported that pickle library. I think we talked about it right in here. So import pickle, and that's how I'm going to dump my executable into pickle, so my Flask can pick that up from that point onward. So that's how I trained and deployed my model using the catboost algorithm. I found it to be quite useful, quite handy, and we'll get to see how it's served up through Flask. And I can tell you that experimenting with the data, testing with multiple data sets, it turned out that catboost was the way to go. So that's how I ended up selecting catboost. So we'll look into the second part. Please refer back to the second part of this video. So that's where we pick up this pickle model or the pickle file, and then we are going to use Flask to serve that up. I hope to see you there in the second part. Thank you.